Okay, so we're now ready to get into a very important topic in mathematics, this concept of a polynomial. So that's going to be the big topic of the day, of the whole chapter actually. And it turns out that polynomials occur just about everywhere. We find that they're easy to work with, easy to find their derivative and to integrate them when you move into calculus. They mathematically model situations in business, like my profit, my revenue and my cost, in engineering, vibrations of strings and all kinds of things like that. Polynomials are very, very applicable. So we use them as building blocks for just about everything we do in math. So we're going to basically start learning some of the terminology that goes with the polynomial and then learn to do some operations with them. So it all starts with what I playfully call the jargon or the lingo. Jargon, again, or lingo, is language that goes with a certain topic. And if you've ever been in the military, you know there's all kinds of, like SETCOM and all kinds of different lingo that if you're not in the military, you don't know what they're talking about. Of course, in some workplaces, you have the same thing. People call a certain HR document something, or they call a certain set of rules in the office a certain thing. And so, unless you're familiar with it, right, you're kind of lost. And it turns out that polynomials have their own jargon and their lingo. So we're going to learn a few of that stuff in the next couple of videos. And it all begins with this idea of a term. All right, and so it has a long-winded definition, and I'll break it down for you. But basically, a term is 3 items. The first thing is that it could be a number. So just pick your favorite number. Maybe it's the number 2. All right, and so that number all by its lonesome can be considered a term, right? Or it could be a variable. So take a variable, let's say x, and just let it sit there by itself, and you now have what's identified as a term. Or it's a product, meaning a multiplication, of a number and a variable raised to a whole number power. All right, and that is a mouthful. So what we mean by that is product means multiplication. So maybe I take my 2 and I multiply it to my x. All right, so I've just formed a product between a number and a variable. And then the key to making a term different than anything else is that the variable is only raised to whole number powers. Recall our whole numbers are 0, 1, 2, 3, 4, and so forth and so on. So for the term that I've built here, right, x is basically raised to the first power. All right, of course we just write that as 2x. All right, and even the variable here, the term here 2, that is basically 2. There is a variable, but that variable is raised to the 0 power. Of course, hopefully you recall that anything to the 0 power is 1, so we're basically talking about 2. So even though a number is by itself, there technically is a variable part to it. It's just risen to the 0 power, and we just don't write it. We just write 2. All right, and so that's basically what we mean by a term. So we can start building a whole bunch of terms. We can have a negative, let's say 5x squared. So I've just built a term because I built a product between the number -5 and the variable x, and it's raised to the 2nd power, which is basically a whole number. And we can just go on and on. You can use fractions, right? So maybe I have 7/2 x to the 3rd, right? And so again, this is an example of another term. It's a product, right, of a number, 7/2. It's being multiplied to a variable x that's risen to the 3rd power. So basically I have another term. And you don't have to continue to use x. You can, use, like, say 10y to the 4th. All right, and so again, I built another term because we're talking about an item, right, that is a product of a number, 10, and a variable, in this case y, and it's being raised to the whole number power, which is 4. All right, and then later on, we can even get more complicated. Maybe we have -3x squared y cubed. Right? This technically also is a term because it fits our definition. Perhaps I should have used the word variables there. Right? So it is a product. Right? This is one giant product of a number, -3, and 2 variables, right, x and y, raised to whole number powers, 2 and 3 respectively. And I just realized that I am off the table there. Sorry about that. So again, so -3x squared y cubed. right, is definitely a term because it fits the definition. It's a product of a number and variables raised to whole number powers. So that's effectively what a term is, right? And then along with the term, there's a couple of other items that come up. One is the coefficient. All right, the coefficient is basically the number part of a term. All right, so let's go back to the definition. Remember, every term has a number and a variable. All right, and so the coefficient is basically the number part. So looking at my terms over here, right, of course the number involved in this term is 2, so there's your coefficient. All right, right here the number involved, technically speaking, there is a 1 in front of it, right? 1 times x is just x. So the coefficient for this term is 1. The coefficient for this term is 2. It's the number part. And the coefficient for this term is -5. Again, it's the number part of the term. For this term, it's the fraction 7/2. For this term, it's 10. And for this term, it's -3. So again, the coefficient is just the number part of the term that I'm considering. And then there's an item that we call the degree of a term. All right, and this is basically the power, or if you want to call it the exponent, right, on the variable. Okay, so if I go back and look at all my terms, right, let's go kind of work in reverse here. That term we're going to come back and visit later, right, because there's some language we have to work with. Okay, but however, for this one, right, the degree of this term would be 4, because the power on the coefficient, excuse me, the power on the variable is 4. This would be a degree term 3, right? So the degree of this term is 3 because that's the power on the variable. This would be a degree 2 term because the power on the variable is 2. This would be a degree 1, right, because it's to the first power. This also would be a degree 1 first power. And then when there is no variable, well, technically there is, it's just risen to the 0 power, this would be a degree 0. All right, and so that should give us a pretty good introduction into this polynomial. We'll define that officially in the next video, but every polynomial basically has all these components. We have terms, right, and every term has a coefficient, a number part, and every term has a degree, right, the power that's on the variable. All right, so we'll on to the next video where we can officially start talking about polynomials.